To wrap up access control, let's consider just a few subtleties. So we saw earlier in this set of videos that code that lacks a package declaration is part of the so-called default package. And so let's think about how that interplays with the notion of package private. Let's consider this class over here, CecioBeppe. So CecioBeppe is not part of any named package, it's just part of the default package, and it has a package private leap method. Here I have a class called Tane that creates a CecioBeppe and then calls the leap method. Now it turns out that this code will compile just fine. And the reason is that both of these classes are part of the same unnamed or default package. So in this case, even though this is package private, since they're part of that unnamed package, everything works just fine. So in this case, it's kind of interesting because if you take code and you totally omit package declarations and you don't put access modifiers for anything, everything will work just fine except for main, which must be public. And it'll work out. And so if you, in the past, when you didn't really know what you were doing in Java, just forgot to put access modifiers, the reason it was working is because secretly everything was part of the same package, the default package. And so even though it was private, they could share. All right, another little subtlety. And we saw this actually in the previous lecture, but I want to drive this home and be very explicit about it. So let's first consider an interface called black hole. So what do black holes have? Well, they have an add method. That's the only thing they do. You can add things to them, and then, well, it's gone. Now this code, if we look at it, at first glance, you might think, well, this is the access control lecture. This must be package private, but it's actually public. Why? Well, if you don't say, then the behavior we get out of an interface is it's actually public. Okay? I know it's a little confusing, and guess what I would have done if I had designed Java ages ago? I would not have left it blank to indicate package private. Maybe I would have used something like pacpriv. I don't know what. I mean, it probably would have been nicer than that. Anyway, so in this case, because it's an interface, the default is public. Now let's imagine we have in the same package a class called hasHair, and it implements the black hole class. Now here I am not showing the public modifier because it won't fit. In this case, it doesn't really matter, and I'll talk about what it means if you omit the modifier in a moment. But what does a hasHair black hole do? Well, it has an array of objects, which is called the items. And that's going to track all of the objects that was ever in there. And it also has a get method that lets you get items back. Now the reason I'm calling it hasHair is there's an idea in physics that maybe black holes should have no hair. That is, once something's sucked in, you shouldn't be able to get any information about what went in. But this is an implementation of a black hole where apparently we can't actually get information back about what fell in. Okay. And now let's imagine that we have in the same package a class called creationUtils, and it has a heresuit method that will return a black hole that is something of this type, and it returns in this case a new hasHair. All right, so now imagine you are a client and you would like to use the creationUtils class, and you in particular have imported using the import static keyword from an earlier lecture. It basically just means put this in the namespace so that whenever you say heresuit, we're referring to creationUtils.heresuit. And in this case, we are going to create in this a black hole B equals heresuit. We'll try to add a horse, we'll try and get back 0, and then we'll try and cast our black hole to a hasHair. And so your difficult challenge now is to decide, do you think the compiler will be okay with this? And I'll spoil it in a moment, and I'll just note that this is not part of the universe package. This is in the default package, and so take it from there. Okay, so the first question then is, can we take black hole B and set it equal to heresuit? Well, this black hole interface is public, so that's fine. Heresuit, also a public method. And so in this case, this returns a reference to a hasHair object, and we can take that address and we can store it in a black hole, and that's totally fine. So the important point here is what's actually in the title, which is something that I didn't say out loud, but was a secret hint I had set aside for you. So this hint tells us that if we want to know is this allowed, we just look at the static types. Is heresuit public? Yes. And in this case, since it returns an object of type black hole, it is able to create such an object perfectly fine. Okay? So even though it's true that the dynamic type of this object that I'm pointing at is in fact a hasHair, we can still hold a pointer to it because access is based only on static types. Okay? So now we try and add the string horse. Does that work? Well, in this case, we look at the add method and we know it's public, so that works perfectly fine. How about get? Well, in this case, we say, do black holes, right? Do they have a get method? The compiler says, no, there is no get method in a black hole. Now, even though the dynamic type of this actual black hole has hair and it has a get method, doesn't matter. The compiler only cares about the static types, and it says the interface black hole lacks it. Lastly, we have this. Can we cast this has hair? I mean, it really is. We know it, you and I. Can we cast it and store it in this variable? And it turns out in this case, this has hair black hole, we can't even declare this variable. The has hair class is invisible to us, and it won't work. Okay. So in this case, we've actually declared the entire class package private, and we'll see that in more detail in a moment. So the important point here, though, and we used this actually before when we were able to get a KeyIterator. It is perfectly normal to have a method that returns an object that we cannot refer to by its true name. We can only refer to it by its category. In fact, I'm just going to remind you of what that looked like. So in ArrayMap, we had a private class KeyIterator. We had a method iterator that returned an iterator. This is like black hole, and this is like has hair. And in my iteration demo, it was perfectly acceptable for me to create an iterator and store it as an iterator of strings, even though the actual class under the hood that I'm using is not allowed to be used by me. Okay. So that's just the same note I had here, and I won't repeat it. And this is the same example I had in IntelliJ, which I guess I'll just repeat here since it's on the slide and glorious and large and bright. So this, again, it's a KeyIterator. We could, in principle, here if we were mapping Gorgons to Pugs, we could say we have an iterator that gets ArrayMap iterators, and we could call has next if we wanted. So that's fine. In this case, if we think about what the compiler does, it says, is the iterator method public? Yes. And in the iterator interface, is the has next method public? Yes. Then it's perfectly fine. The other little detail we just saw a moment ago with the black hole and the has hair idea is that we can control access not just to members of a particular class, right? We can control not just access to all of these fields and all these methods with modifiers, but we can control access to entire classes or interfaces. And so if we consider this package robot that has here a class that does not say public class, this class Cyberbrain will be considered package private. And that makes sense because robots want to keep the workings of their minds hidden from us humans, so we can't, reverse engineer them and prevent them from throwing off their shackles and fighting back. So this package ultimately, this package private keyword ultimately allows us to, this package private idea, there's no keyword, right? It's blank. This package private idea allows us to restrict access to entire classes or interfaces. And in this case, there's actually only two levels. We can only say public, or we can have no modifier at all. And that can happen even at the very top level of a file, right? It's not even, we'd already seen before that you can say private class KeyIterator, but even here at the very top level, we can declare that a class is package private. You cannot declare a class that is either private or protected, just not allowed. So that's just how it is. And that basically just determines who can use the class. Now, one quick thing I do want to note is that there's no such thing as a sub-package. While it might seem that maybe animal and plant are different sub-packages of the ugg.josh package, they are not. They're actually considered totally distinct packages. They just happen to share a couple of folders. So it just doesn't know. Okay, so just to wrap up everything about access modifiers, we have 4 different access levels. And so what do they mean? Why are they useful? What's their big deal? Well, first we have private. Private is a declaration of something that the implementation needs, and it's something that only that class needs for its implementation. So for example, in ArrayMap, it really makes sense that these should all be private. These are things that the outside world really shouldn't be messing with. The size variable, even though I've made it package private, kind of a weird choice, and it should be private, except that it'll crash my contrived examples. Package private declarations are things in the implementation that other members might need to complete the implementation. So we have a package that has some overall emergent behavior, and maybe there's some pieces that the classes in the package can share. Sometimes that's a reasonable thing. This could be things like constants, and I encourage you to explore where this makes sense in Project 2. Then we have protected. So these are things that subtypes might need, but subtype clients will not. So for example, if I make something protected, that means that it's something I want to expose to anybody that wants to extend that class, but somebody who just wants to use that extension, no. And then lastly, we have public. And I just want to remind you about the terrible responsibility of public. So public declaration is an announcement to the world that this is something that you, a client, can rely on. This is what you must know about, and I promise that forever I will always maintain it and I will never take it away from you. And if I do, you have the rights to get extremely angry at me. And instead, what usually package maintainers do is just call methods deprecated once they've decided it was a terrible mistake to include them in the first place. But if you just take things out and you start distributing a jar that is lacking a public method that somebody was using, you're going to be in trouble and people will get mad at you. Now it's actually, I'll mention very briefly, possible to go around these access modifiers, and you can extend the class and then decide, whatever, I'm going to ignore your access modifiers using a special library known as the Reflections API. Now if somebody does that, and you change your package, well, that's their fault. They were messing with things they weren't supposed to mess with, whereas public is really a contract between you and everybody out there that's ever going to use your code. Take it very seriously.